Greetings everyone. Beforehand, I would like to thank to all the participants because we as SGD Battery can present our paper entitled Adaptive Immunity. Let me introduce myself. My name is Yanti Graciella with my last 3-digit number is 162. This is our member of SGD Battery. Then we can start with an introduction.
Thanks for the opportunity. First, I'm going to introduce myself. My name is Sienny Kuswardi with the last three digits of my student number is 004. We're going to start off with the introduction. For the background, there are two main lines of defense in the immune system, which are innate immunity and adaptive immunity. Together, they play a crucial role in maintaining health, and deficiency in either system can result in diseases such as autoimmune diseases, immunodeficiency disorders, and hypersensitivity reactions. Adaptive immunity has the capacity to create memories, enabling the host to trigger a more potent immune response when the antigen is pre-exposed. It is an antigen-dependent and antigen-specific. When a particular adaptive immune response is developed against self-antigens, autoimmune disease results and hence the effector pathway of immunity causes tissue to become chronically inflamed, which may be fatal. Therefore, it is important to understand adaptive immunity in order to prevent and develop cures for adaptive immunity diseases. Next, we talk about the problem formulations, which are what is the definition and structure of adaptive immunity, what are the types of adaptive immunity, what are the differences between types of adaptive immunity, what is the function of adaptive immunity, what is the process of forming adaptive immunity, what is the adaptive immunity pathway, what are the adaptive immunity diseases, and what is the adaptive immunity from vaccines. And then for the purposes, to explain the definition and structure of adaptive immunity, to give information about the types of adaptive immunity, to tell the differences between types of adaptive immunity, to understand the function of adaptive immunity, to describe the process of forming adaptive immunity, to comprehend the adaptive immunity pathway, to explain adaptive immunity diseases, and to understand adaptive immunity from vaccines. Lastly, for the benefits, the function of this literature is to give proper information about adaptive immunity. This literature explains about the definition, structure, types, differences, function, formation, process, pathway, and diseases of adaptive immunity. We sincerely hope this literature can give a great insight about adaptive immunity and will contribute to the improvement of its knowledge. That's all from me. Thank you.
Hello everyone, my name is Patricia, Clarine, Simpson with the last 3-digit number 125. Today I'm going to explain about the definition and structure of adaptive immune. So the immune system is divided into the innate and adaptive immune system. The innate immune system acts as a first line of defense and is non-specific. Meanwhile, the adaptive immune system can create highly specific immune responses to a particular pathogen, but it's important to note that it takes time. The adaptive immunity is defined by immunological memory, which can make the immune system respond quicker to pathogens and improve the potency of responses when the same antigen invades again in the future. So talking about the structure of adaptive immunity, it is divided into two main responses, which are cell-mediated immune responses and antibody responses. The adaptive immune system is made up of lymphocytes, which are B and T cells. B cells carry out the antibody responses, meanwhile the T cells carry out the cell-mediated immune responses, which will be explained more clearly in the next few slides. That's all from me. Thank you very much for listening.
Let me introduce myself. My name is Yanti Graciella. With my last 3-digit number is 162. I will explain the next part. There are two major groups of adaptive immunity, cellular immunity and humoral immunity. Humoral immunity is mediated by proteins called antibody, so they can enter the circulation and neutralize extracellular microbes. Humoral immunity will be responded by B lymphocyte cell. Meanwhile, cellular immunity functions to neutralize microbes that are intracellular. Cellular immunity will be responded by T lymphocyte cell. T lymphocyte cell can activate phagocyte to destroy microbes in cell. There are two ways cellular immunity works against microbes. The first type is phagocytosis, and the next type is self-entering. The lymphocyte cell responses by cellular immunity are T helper lymphocyte and cytotoxic lymphocyte.
My name is Dewi with the last two digits of my student numbers are 146. Adaptive immunities are classified as either humoral immunity or cell-mediated immunity. Humoral immunity is a type of adaptive immunity in which B cells release antibodies that circulate in the blood as a soluble protein. The other component of adaptive immunity is cell-mediated immunity, which is mediated by activated antigen-specific T cells. Humoral immunity is mediated primarily by B cells, with T cells and macrophages following, whereas cell-mediated immunity is mediated primarily by T cells, with helper T cells, cytotoxic T cells, natural killer cells, and macrophages following. Extracellular microorganisms and their toxins are targeted by humoral immunity, whereas intracellular microbes such as viruses, bacteria, parasites, and tumor cells are targeted by cell-mediated immunity. B-cell receptors, or BCR, are involved in humoral immunity, whereas T-cell receptors, or TCR, are involved in cell-mediated immunity. IgA, IgB, CD4 T lymphocytes, CD21 lymphocytes, and Fc receptors are humoral immunity accessory receptors, while CD2, CD3, CD4, CD8, and CD28 lymphocytes, also integrins, are cell-mediated immunity accessory receptors. Humoral immunity recognizes unprocessed antigens. In cell-mediated immunity, the major histocompatibility complex, or MHC, processes and presents antigens. Antibodies are secreted by plasma B cells. T cells produce cytokines. Cell-mediated immunity affects tumor cells and transplantation, but humoral immunity doesn't.
Thank you for the opportunity. My name is Putu Chandrika Rahma Dewi with the last 3 digits students number 071. So here I will continue to present about the function of adaptive immune systems. The immune system's main function is to fight germs and foreign substances on the skin and the tissues of the body and in the bodily fluids. Particularly in the adaptive immune systems, this has a crucial function to fight and destroy specific invading pathogens and any toxic molecules they produce. And also, it can save humans from certain death by infections. There are 2 types of adaptive immunes, such as from the cell-mediated T lymphocyte and from the humoral B lymphocyte. T lymphocyte contains CD8+, which will lyse the pathogen by releasing perforin and encourage the recruitment of more cells to infection sites by releasing a variety of chemokines. Particularly, CD4+ are crucial for the development of the memory subsets of CD8+ reacting lymphocyte. Also can employ chemical messengers to activate other immune system cells, leading to the elimination of viruses and the removal of the dead cells. Lastly, B lymphocyte cell can produce antibody and antigen presenting cells to support other mononuclear cells and directly influence inflammatory pathway. Okay, that's all for me. For the next speaker, time is yours.
Hello everyone, my name is Putu and Nirajanari and the last 3 digits of my student number are 049. I'm here about to explain the formation process of adaptive immunity. So we start with the B cells first. Process of B cells in the bone marrow start from the common lymphoid progenitor or CLP that develop into pro-B lymphocyte cells regulated by surrogate L chains or SLC with 2 proteins that will bind to microprotein in the H chains to form a pre-B cells receptor or BCR. Then pro-B lymphocytes develop into B cells precursor by expressing pre-BCR to the surface of their cell. The B cell precursor will form an IgM receptor on the cell surface and make it an immature B lymphocyte cell. Immature B lymphocyte cells are divided into 2 types, namely T1 and T2 transition cells. These immature B lymphocyte cells can already leave the bone marrow and go to the spleen to mature through transitional cell stage into naive B lymphocyte cells, follicular zone, or marginal zone and will develop further at the secondary lymphoid organ. That's all from me. The next slide will be presented by my friends. Thank you.
Let me introduce myself. My name is Bagus, Tresna, Indra, Putra, Pramana with the last 3 digit number 104. And now I will continue to the formation process of T lymphocytes. T cells originate from a common lymphoid progenitor in the bone marrow that also gives rise to B cells. However, the offspring that will eventually become T cells migrate off the bone marrow and into the thymus for maturation, selection, and subsequent export to the periphery. Peripheral T cells are composed of many subsets, such as regulatory T cells that regulate immune responses, memory T cells that preserve long-term immunity derived from prior antigen activation, and naive T cells that can respond to novel antigens. Early in life, naive T cells have recently erupted from the thymus make up the largest proportion of T cells, while Treg cells are also considerably represented. Adult T cells have different functions than those of children, as evidenced by the shift in the T cell predominance from naive to memory after childhood and the greater stability of immunity through decades of adulthood. The role of T cells changes to maintain homeostasis and immunoregulation in the context of repeat and chronically encountered antigens in adulthood, when tumor surveillance is also crucial in T cells.
Allow me to introduce myself. My name is Yohanes Putra Sunardi with the last 3-digit number 089. Humoral immunity focuses on defending the extracellular space in the body, managing by B cells. Naive B cells can turn into memory B cells or plasma cells through activation through two pathways. T cell independent. Certain antigens like glycolipids directly activate B cells by connecting antibodies on the B cell surface. T cell independent. Other antigens, such as globular protein, requires assistance from CD4 T cells. Antigen-presenting cells (APCs) presents the antigen to T cells with MHC class II molecules and triggers them to produce cytokines, leading to B cells activation. Activation B cell can be followed two paths: become short-lived plasma cells or settling in germinal center. In the germinal center, B cells can change their antibody type, class switchings, and undergo mutation, somatic hypermutation, for increased effectiveness. This process, known as affinity maturation, produced high-affinity B cells and long-lasting memory B cells. Antibodies from B cells do a lot in humoral immunity, such as neutralization. They can stick to microbes to stop them from infecting cells. Opsonization, when IgG makes microbes more attractive to phagocytes for ingestion. And complement system activation, like IgG and IgM activates a system that can destroy microbes. And passive immunity, such as IgG can pass through the placenta to provide immunity to the newborns. Antiparasites, like IgE, helps kill parasites. And mucosal tissue protectors, such as IgA, that protects mucosal tissue from microbes.
Hello, doctor. Let me introduce myself. My name is Michael Jonathan Raya, with 3 last digit student ID number 182. Now I'm going to explain about the cell-mediated pathway. Cell-mediated pathway is an immune response mainly involving T cells. T cell will become mature in thymus, and most of it died because of selection process in the thymus. When microbe enters the body, antigen-presenting cells or APCs will capture it. The APCs will produce MHC class I and class II molecule to display the antigen. T cell will then recognize this antigen by several mechanisms. First is the primary signaling, is the binding of antigen and T cell receptor, also binding of CD4 or CD8 receptor to MHC molecule. And the second one is co-signaling, occurs when CD28 receptor at T cells bind to B7 protein at the APCs. After T cell react with APCs, it will activate it, leading to activation phase. CD4 helper T cell secretes interleukin-2 cytokine, which will stimulate the proliferation of T lymphocytes. The activated CD4 T cell will differentiate it into several effector cell types, such as T helper 1, T helper 2, and T helper 17. On the other side, the activated CD8 T lymphocyte will proliferate and differentiate into cytotoxic T lymphocytes, CTL, or T killer cells. These cells kill intracellular or cytoplasmic microbes, triggered by the binding of MHC class I molecule. CTL destroy microbe through a mechanism called perforin granzyme system. Perforin will create pores for granzymes entry, while granzymes then enter the cell through the pores and induce cell apoptosis. After the infection has subsided, the adaptive immunity will enter decline phase. In this phase, memory cells live longer, guarding the body from another same antigen infections. There is also a regulatory or suppressor T cell, which controls the decline phase of the immune system, preventing hyperreaction of T cells. And that's all from me. Thank you.
Hello, doctor and friends. My name is Patricia Orlyn Jotan, and the last 3 digits of my student number is 171. Now I want to explain about the adaptive immunity from vaccine. A vaccine is a biological substance designed to trigger a safe immune response, providing protection against infection or disease upon encountering a pathogen later. To accomplish this vaccine needs to incorporate antigens, which can be sourced from the pathogen itself or is artificially created to mimic its components. Our immune system ability to remember past infection is one of its main characteristics. This exposure can come from vaccination or infection, and by keeping in mind that we are ideally completely immune to illness should become into contact with the same pathogen again in the future. The immune system retains the ability to recall infection it has previously encountered, and memory, B, and T cells play a crucial role in secondary infection responses. The adaptive immunity response relies on B cells for antibody production or humoral immunity and T cells for cellular immunity. With the exception of BCG, which is believed to elicit T cells response preventing severe disease and innate immune response hindering infection, all routinely used infection are generally believed to provide protection primarily by inducing antibodies. So, the process of immune response to the vaccine starts when the immune response triggered by a conventional protein antigen immunization. It involves injecting the vaccine into the muscle. Then, dendritic cell uptake the protein antigen, get activated by dangerous signals in the adjuvant through pattern recognition receptors, and then migrate to the draining lymph node. In this lymph node, the presentation of peptides from the vaccine protein antigen by MHC molecule on dendritic cells activates T cells through their T cell receptor. Simultaneously, signaling through the B cell receptor by soluble antigen assisting in driving B cells development. T cells dependent B cell development in the lymph node leads to the maturation of the antibody responses, enhancing antibody affinity and inducing various antibody isotypes. Short-lived plasma cells are produced, actively secreting antibodies specific to the vaccine protein and cause a rapid surge in the serum antibody level over the next 2 weeks. The process also resulted in the generation of memory B cells responsible for immune memory. Long-lived plasma cells capable of producing antibodies for decades migrate to reside in the bone marrow niches. CD8 memory T cells can swiftly proliferate and upon encountering a pathogen, and CD8 effector T cells play a crucial role in eliminating infected cells. So, in conclusion, when faced with a pathogen, an individual who has received vaccination against that particular pathogen can initiate a protective immune response more swiftly and effectively. That's all from me. The next slide will be explained by my friends. Thank you.
My name is Komang Surya Mahottama with the last 3 digits of the number 221. Adaptive immunity is referred to as acquired immunity or specific immunity and is only found in vertebrates. The adaptive immune response is specific to the pathogen presented. The adaptive immune response is meant to attack non-self pathogenesis but can sometimes make errors and attack itself. When this happens, autoimmune disease can develop. Example, lupus, rheumatoid arthritis. Lupus or lupus erythematosus is a chronic autoimmune disease that can cause inflammation in several parts of the body, such as the skin, joints, kidneys, and brain. While rheumatoid arthritis is long-term inflammation of the joints caused by the immune system mistakenly attacking the body. Rheumatoid arthritis is classified as an autoimmune disease. The cause of autoimmune disease itself is not yet known with certainty, but it is thought to be related to genetic factor. Thank you.
Hello, my name is Wildan Sifa'ul Mahsyar with the last name number is 174. So now about conclusion. Adaptive immunity is an immune system that is specific and able to form memories, allowing the host to respond more effectively to a specific pathogen. Consisting of lymphocytes, namely B cells and T cells, adaptive immunity functions to fight specific pathogens by destroying, blocking, or neutralizing the pathogens that enter the host. B cells have the role of producing immunoglobulin proteins called antibodies, performing humoral immunity that neutralize extracellular pathogens. On the other hand, T cells generate immunity, cellular immunity that destroys pathogen in the host cell by phagocytosis or by recruiting other immune cells to the site of infection. Both humoral and cellular immunity have various pathways that work in harmony to generate our immune systems and need the innate immune system before they can work. vaccination triggering our body to form antibodies that make our immune system deal with pathogens more swiftly and effectively on the next infection. However, sometimes our adaptive immunity makes errors and attacks itself, leading to autoimmune disease. So that's our presentation about adaptive immunity. I hope you can get helpful knowledge from this presentation. Thank you for your attention. Stay healthy and be well.